Okay, well, last time we finished up chapter 2. Today we're going to get into chapter 3, which really starts the meat of organic chemistry. So without further ado, let's get into the meat, or some of the meat of organic chemistry. This chapter is divided into a few sections. The first section starts off by how to name organic molecules. And then we later get into a section of dealing with cyclic molecules and stability of molecules. Okay? So that's the kind of order we're going to proceed in. So let's go ahead and start with some of the basics. Okay? First thing to look at are what are called hydrocarbons. Hydrocarbons. Okay, you probably hear about these in the news and so on. But if you break down what they are, you got hydro and carbon. As you might guess, hydro stands for what? Hydrogen. And carbons. So hydrocarbons are just simply molecules made up of carbon and hydrogen. Pretty straightforward. And with hydrocarbons, we have two categories. You have what are called saturated hydrocarbons and unsaturated hydrocarbons. Okay? So what are these? Okay? Saturated hydrocarbons means that we have as many hydrogens as possible in the molecule. You think about a sponge. A sponge that is saturated with water means what? That it holds as much water as possible. If you added any more, it couldn't hold any more. Well, the same thing with a molecule that is a hydrocarbon. It has the maximum amount of hydrogens as possible. And these are basically made up of all carbon-carbon single bonds. Okay? So for example, a very simple hydrocarbon that is saturated would be this one here. Okay? So this would be a saturated hydrocarbon. What would an unsaturated be? Well, that means what? I have to remove some hydrogens from the molecule. In fact, if I remove, say, the top two, to give me that there, how many bonds does each carbon have when I take away those two hydrogens? 3. Remember, carbon always has to have 4 bonds, tetravalent. So what happens is I insert a double bond. Okay? So we've learned that for something to be unsaturated, I need to have at least a double bond in there. Okay? So fully saturated, unsaturated. What would happen if I did this? And put a triple bond. What happens? My unsaturation becomes what? More, because I took away 2 more hydrogens. So this is even more unsaturated. Okay, so the more hydrogens I take away, the more unsaturated it gets. So we will always see unsaturation with both double bonds and triple bonds. If I have single bonds only, I don't have any element of unsaturation. It's fully saturated. Okay? So let's develop this a little bit more. Let's suppose I wanted to write the molecular formula for this. That would be what? 2 carbons, so C2. Then I got 6 hydrogens, don't I? C2H6. What would be the molecular formula for this one? C2H4, right? Then lastly, take away 2 more hydrogens. So we get C2H2. Okay. Well, as we stated earlier, you can get increased amount of unsaturation. Well, this way of measuring how much unsaturation we have is something called the degree of unsaturation. The degree of unsaturation, or sometimes we will abbreviate that du. Okay? What is the degree of unsaturation? Okay? It's equal to the number of hydrogens missing divided by 2. Okay? That's a very important definition. Write it down and put a box around it. Okay? Let's see how we can use it to these molecules over here. Okay? This one does not have any hydrogens missing, so its du is what? 0. Okay? So a fully saturated case has a degree of unsaturation of 0. Okay? Here, I took away 2 hydrogens. So the du is 2 over 2, which equals 1. Which equals 1. So here, this 1 represents I have 1 degree of unsaturation. What about with this triple bond? I've taken away what? 4. Okay? I've taken away 4 from the original state. And so 4 over 2 is 2. So now my degree is 2. Okay? I have 2 degrees of unsaturation. Okay? Let's continue this here. Let's suppose I had this here. I want to know what degree of unsaturation does this have? Very simple, isn't it? I have 4 double bonds, and I know each double bond is 1. So I have 4 of them, so the du is 4. Okay, so that's a pretty unsaturated molecule there. Okay. Let's take a look at this here, where I have this 5-membered ring versus this 5-membered linear molecule. Okay, what's the molecular formula for this? 5 carbons. And if you were to count the hydrogens, you would get 12. Okay, you should be able to do that by now. What about for this one here? Well, I got 5 carbons, and I have how many hydrogens? 2, 4, 6, 8, 10. So C5H10. So this molecule is fully saturated, isn't it? Okay, because there's no double bonds or anything. But look what happens when I make the ring. I lost 2 hydrogens. So this thing here has a du of 1. Here we just learned an important principle, that a degree of unsaturation of 1 means that the molecule has either a double bond or a ring in it. See that? So write down, anytime I have a ring, that takes up 1 degree of unsaturation. Okay? It forces me to lose 2 hydrogens from the saturated case. Let's suppose I had that molecule. What would the degree of unsaturation of that be? Well, I got a double bond, that counts as 1, and I got the ring, that counts as 2. And so my degree of unsaturation is 2 there. Okay? Okay. Well, what about if we had this here? Okay, now I throw up oxygen in there. Okay. What would the degree of unsaturation be here? Well, I got a ring, so that counts as 1, a double bond, 2, a double bond, 3, and another double bond, 4. I don't care if the double bond's connected to a non-carbon atom or not. It still counts as a du. So I get 4. The ring, 2, 3, and 4 for those double bonds there. Okay. All right, well, let's continue to use this degree of unsaturation, okay? But now what we're going to work with are molecular formulas, okay? Let's suppose I had a molecular formula of C10H10. How could I figure out the degree of unsaturation of that? I have no idea what the structure is. I just have the molecular formula. Okay? Well, in order to have a standard for our fully saturated case, okay, we need a standard for that, and that standard is CnH2n plus 2. Okay? So what would the fully saturated case be for a C10 molecule? Okay? So N is 10. And now my hydrogen count will be what? 2 times 10, 20 plus 2. So it'll be H22. Okay, so this is the fully saturated molecular formula for C10. But what I have is C10H20. So what I can do is subtract to get to see how many hydrogens are missing. So if I subtract, supposed to be 10 there. So if I subtract, I get 12. So I have 12 hydrogens missing. So now if I use my DU formula, I would have 12 over 2 for 6. So my degree of unsaturation would be 6 for this molecule. You might say, what would a possible structure be? Well, just to try to be creative, you can maybe have a ring of 6 carbons for 1 DU, 3, 4, 5, and put on an attachment out here for another double bond. Okay, so there would be a total of 6 for the DU. Ring 1, 2, 3, 4, 5, and I need one more for 6. Okay, so that thing is really unsaturated, all those double bonds in that ring. Okay, let's look at another case. Okay, let's suppose we had C8H14. What's the degree of unsaturation? Okay, so again, I need the fully saturated case. So N is 8 times 2, 16, plus 2, 18. So there's my standard saturation. Now I will subtract what was given to me. And so I see that I have what? 4 hydrogens missing. So if I want to use my DU, my DU this time will be 2. Okay, so I have 2 degrees of unsaturation. Okay, so what are some possible structures for this? Well, I could just draw 8 carbons, and I could put in simply 2 double bonds. That's one option. Or I could put in 8 carbons and a triple bond, takes up 2. Okay. Or another option, maybe draw a ring. So there's 1, and then put another for 2. Okay. So there's many possibilities. Okay. We have no idea which is the right one, but these are possible structures that meet the requirement for a degree of unsaturation to be 2. Okay. All right, well, let's look at some other things with this degree of unsaturation. Sometimes we can have other atoms in the molecule. Okay. So for example, Let's suppose we had an oxygen atom in the molecule. Okay, but an oxygen atom, something like that, that has a molecular formula of C2H6O. Okay. Remember, the fully saturated case for C2 is what? C2H6. So what did the oxygen do to the hydrogen count? It did nothing, did it? So this is the first rule. If I have an oxygen in there, it does nothing to my hydrogen count. Okay? You say, what do you mean by that? Let's take a look at this here. Let's suppose we had this molecular formula, C8H16O2. Okay? Well, this does nothing to my hydrogen count, so this is basically acting as C8H16. Okay? So my fully saturated case would be C8H18. If I subtract the 16, I get 2, and then divide by 2. So my du is 1 in this case. So a possible structure for this might be something like that, where I use my du in the ring, and I got one oxygen or an OH, and then maybe put another OH over there. So this here would fit C8H16O2. I know there's 16 hydrogens there. You may want to check it out, draw them all out to make sure that there are 16 hydrogens, and then we have the 2 oxygens. Okay? So that's the first case if we have another kind of atom. Let's look at a second case. A second case is if we have a halogen in the molecule, a halogen. What will this do to the hydrogen count? Okay. Let's suppose we had a fluorine in there. Do you see what the fluorine is doing to the hydrogen count? It's basically acting, substituting for a hydrogen. So this molecular formula is C2H5F. There's no double bond in there. So basically the fluorine, what I do is I add one to the hydrogen count. So this thing is acting like C2H6. Okay? So you want to write it down right here, that when you have a halogen, for however many halogens you have, you add those number to the hydrogen count. Okay? Let's take a look at an example. Let's suppose we had something like that. I want to figure out the degree of unsaturation. Okay, so what do? I have 10 hydrogens, but I'm going to add my halogens to those, so that'll give me, quote, 14. Okay, 2 here and 2 there. My fully saturated case is again C8H18. So my DU is 2 this time. Okay. So here I could draw a possible structure for 2 degrees. So there's 6 carbons, 1 DU, another DU, and then finish for 8 carbons, and now put on my halogens. Doesn't matter where I put them on. Put them on like that, for example. It doesn't matter. So there, that molecule automatically has a DU of 2, and it has 10 hydrogens in it. Okay, this down here, this is just a fictional thing incorporating these halogens. You can forget about that at that point. But this molecule has 10 in here for that. Okay, so that's what happens if we have an oxygen, halogens, okay? Halogens, like bad breath, it adds bad breath to you, so I have to add to the hydrogen count. Let's go to the last category. And that's if we have a nitrogen. If we have a nitrogen, what does that do to the hydrogen count? Let's look at a molecule like that. And what's the molecular formula? C2H567. And then we have our nitrogen there. So, what does the nitrogen do? Well, again, there's no degree of unsaturation, so the fully saturated case is 6, right? But I'm 1 above it. So the nitrogen, I have to N negative, subtract. Okay? So write it down. For every nitrogen I have to subtract a hydrogen to see what case I'm looking at. Okay? Let's look at an example. Let's suppose we had a molecular formula of this, C8H15N3. Okay? So what am I looking at here? 15 now minus 3. Okay, so it's acting as H12. Okay. So my fully saturated case is again C8H18. Let's subtract H12, so we get 6, divide by 2. So my degree of unsaturation here is 3. So what would be a possible structure for 3? Well, let's draw a ring for 1. And we got 2 more carbons. Okay. So now I can put a double bond for 2, another one for 3. I got 3 nitrogens. So I can make those NH2s. Something like that. Okay? So when you draw a possibility, draw all your elements of unsaturation and then put everything else on the molecule. So I invite you to count all the hydrogens. You will find that they add up to 15. Okay? So that's how you handle these degree of unsaturation problems. Your book gives you more examples of these. Then you want to master these. Okay? You want to be able to handle molecular formulas that I can give you and figure out the DU. And then secondly, be able to draw a potential structure. Okay? Remember, there's no correct structure. Just draw one that matches the correct degree of unsaturation. The second kind of problem that you would get is if I drew a molecule like this and I asked you what is the degree of unsaturation, we would simply add them up. The ring counts for 1, double bond 2, double bond 3, so the DU is 3. Okay? All right, so that is handling the degree of unsaturation. Okay? All right, well, let's come back to our naming process. This was kind of a deviation in the whole scheme of things. But let's come back to our hydrocarbons. Okay, so again, these are made up of simply carbon and hydrogen. Okay, well, in the hydrocarbons, there turns out to be 3 kinds: alkanes, alkenes, and alkynes. Okay. So remember these alkanes okay, all the carbon bonds are single bonds. Alkenes, what are those? I have at least 1 double bond in the molecule. And an alkyne, remember, I have at least 1 triple bond in the molecule. Okay? Now, under alkanes, there turns out to be 3 kinds of these. One kind is what's called the straight chain alkanes. Secondly, you have what are called branched alkanes. And then thirdly, you have what are called the cyclic alkanes. Okay? So what do these things mean? Straight chain, branched, and cyclic. Okay? Pretty straightforward. a straight chain alkane. Okay, just something like that, where the chain just goes straight across. Okay. A branched alkane is something like that, where, note, it's not just straight across. Now I got this branch sticking off, almost like a branch off a tree. Okay? So you can have that, or okay, or I can even have more branches like that. Okay? But here I would have like what, one branch. This would be 1, 2, 3 branches. Okay? So molecules can start getting very complex when they have a lot of branches. Then the third kind, cyclic alkanes. Okay, we've kind of already covered these, where they're ring-like structures. Okay, and those can have groups sticking off them as well. Okay, so those are our categories of alkanes that we want to start heading into being able to name those. Okay? You should know right now what these represent in terms of carbons being bonded to carbons and how many hydrogens. Okay? How many hydrogens that one has? Only has one. And so on. Okay? Again, you should be able to translate those to CH2s, CH3s, and so on. Okay? But now we want to commandeer these molecules under a different domain. We want to have command of them over by naming them. Okay? By naming them. Okay? That was one of the ways that Adam and Eve showed command or ownership over the animals, is that they named them. They named them. Okay? So they had authority over them. So we're going to gain authority over these molecules by learning how to name these. Okay? So we'll go ahead and stop there for today and learn how to name these next time.